Hello everyone, Alan Sens here, and welcome to this segment on the command and control of nuclear weapons. In this segment, we are going to be looking at how the political aspects of the control of nuclear weapons work and how the military aspects of the command and control of nuclear weapons work. So let's get started. Here are the learning objectives for this segment. By the time we're done, you should be familiar with the motives behind nuclear command and control systems, and you should be able to describe how these systems work at a conceptual level. So let's take a look at motives first. So in general, all military command and control systems do two things. And the first thing they do is to ensure that there is an effective communication between commanders at all levels. And secondly, they ensure that effective control of the military is under political leadership. So these are the two main dimensions of all command and control systems with respect to the militaries and civilian control over the military. And that's why so much interest has been extended towards the command and control of nuclear weapons in particular, because nuclear weapons are different. They're not just like conventional military forces. And so a great deal of time, effort, and a lot of literature, academic work has been done on the command and control of nuclear weapons. Here's a couple of examples. One rather old one, decades old, Paul Bracken's now classic study, The Command and Control of Nuclear Forces, and a more recent book by Eric Schlosser called Command and Control. I know it doesn't look recent, but it's just got kind of a retro-looking cover, but it's a relatively new book. And I highly recommend it. If you're interested in this subject, this is basically your first book to read. So all that attention on the command and control of nuclear weapons has basically been focused on the following elements, the following objectives. First, to ensure that nuclear weapons can only be used based on appropriate political authorization. Second, to ensure that should political authorization be provided, nuclear weapons can be armed and launched in a timely fashion. Third, to ensure that warheads are not used by allies on whose territory they may be based. So during the Cold War, for example, the United States based nuclear weapons on the territory of its NATO allies, including earlier in the Cold War in Canada. So obviously, what you don't want is your allies taking control of those nuclear warheads and firing them. So this was an important consideration during the Cold War. It's perhaps a bit of a less important consideration today. Finally, to ensure that military commanders cannot launch nuclear weapons on their own initiative. So you can see in this aspect of the command and control of nuclear weapons, these objectives, there's very much this concern over political authorization on the one hand and military capacity and military control on the other. So, in a sense, command and control systems do two things. They've got to be able to prevent the use of nuclear weapons without right authority meaning the appropriate political authority, and they must be able to ensure the effective and rapid use of nuclear weapons should that right authority be given. And so in this sense then, a quick and easy way of thinking about nuclear command and control is that these systems are both triggers and safety catches. They allow nuclear weapons to be used and used quickly if the correct authority is given, but they also act as a safety catch to ensure that weapons are not used in an unauthorized manner. Triggers, safety catches. Okay, let's take a look at the US model as a case study. Now, all command and control systems are a little bit different, but we'll focus on the US model. It's the one we know most about, and it's the one that's probably the most interesting. So the US model is based around something called the two-man, or these days, two-person rule at the political and military levels. So the whole idea here is that, first, in principle, no one individual is able to launch a nuclear weapon system on his or her own. So it requires at least two people, and that is the essence of the two-person rule. Now, the two-person rule applies at both the political level, and it also applies, at the military level. Let's look at the political level first. And in the United States, this is what that means. The President of the United States has the authority to launch the American nuclear arsenal, to use American nuclear weapons. Only the President can order the use of U.S. nuclear weapons. But in the spirit of the two-person rule, the Secretary of Defense, and that's this person here, that's James Mattis currently, the Secretary of Defense must confirm that order. But this is the National Command Authority of the United States, the Commander-in-Chief of the U.S. Armed Forces, and the sole person who can authorize the use of U.S. nuclear weapons at the political level. The second piece to the U.S. model is that from that point of political authorization, there are two sets of codes. And the first set of codes are the political authorization codes coming from the President of the United States. And the second set of codes are what are called permissive action links, PALs, or sometimes you'll hear the expression use control. And these PALs, or use control codes, are military codes. Now, at the very top level, then, the process of launching U.S. nuclear weapons would begin with the President and the football. And the football has kind of got its own little story in U.S. nuclear weapons history, but anyway, this is the football right here. It's that sort of litigation bag-looking satchel being carried by this U.S. naval officer, and the football is always carried by a serving U.S. military officer who always accompanies the President wherever the President goes. The football contains the Black Book of nuclear attack and retaliatory options, so those would be the options that the United States President would have to choose from in the event of the desire to use nuclear weapons. A book of classified command and control site locations, instructions for the emergency broadcast system, which broadcasts out through basically all media to U.S. citizens, and then, crucially for us, a card with the National Command Authority authentication codes. And those authentication codes are the political authorization codes for the release of U.S. nuclear weapons. So that all begins with the President and the football. And then what happens is things start to work their way through the U.S. chain of command, from the political level eventually to the military level. This chart's going to be really busy and probably hard for you to read on whatever it is you're using, but it's an organizational chart of the U.S. Department of Defense, and there's the Secretary of Defense, who, remember, has to concur with the President on the release of U.S. nuclear weapons. From that point, let's assume the answer is yes, the Secretary of Defense, the system, communicates down through the chain of command to here, Strategic Command. And Strategic Command is the U.S. operational or combatant command that is responsible for controlling the U.S. nuclear arsenal. From that point on, communication is then conducted from Strategic Command to all of the subsidiary commands that control U.S. nuclear weapons. So that includes U.S. nuclear weapons on submarines, that includes U.S. nuclear weapons based on bombers at airfields and so on, and it also includes U.S. nuclear weapons based on intercontinental ballistic missile sites. And so here in this map shows the main sites the United States has to operate nuclear missiles. So these are the locations of the United States Intercontinental Ballistic Missile Fleet. So the Strategic Command then communicates launch instruction, launch order, authentication order from the President of the United States through the football, through the Secretary of Defense, the Department of Defense, down to these ICBM commands. That's when the military codes come in, because there's also then a set of military codes, permission action links, that control the nuclear weapons. In fact, control each nuclear weapon. There's a set of codes for each weapon. PALs enable warheads to be armed and to receive information on targeting, trajectory, and yield, depending on whether or not the weapon has a variable yield device for it. So the whole idea here then is that you've got political codes that are required for the release of U.S. nuclear weapons, the use of U.S. nuclear weapons, and then you've got the military codes that must accompany those orders, those political authentication codes, and the two together are required for a weapon to be used. From that point then, the PALs and the authentication that comes with them flow down to the launch control centers of the US ICBM fleet. So here is a schematic of a launch control center. Much of it, as you can see, is underground here. And so this information, the codes, will come to the launch control center. And from the launch control center, they will go out further to each ICBM silo with its warhead on board. So this is a schematic of a ICBM silo. It's actually an old schematic. I'm just using it because it kind of shows up the best on the video. But the Titan II is retired. It no longer exists. So we're really talking about the US Minuteman missiles here. So here we have the missile in its silo protected by the covering right here, and then the launch control center right here. So the codes will come from the launch control centers and then to the individual launch control centers of each individual ICBM. And then those instructions, those codes, will reach the actual warhead itself. And here's a schematic of a bomb safety system. It's pretty standard. What we have here then is the human intent. So these are the codes coming in, the PALs, which remember accompany with the political authentication with them, and they will go into the control isolation, or what are called strong link systems, for the actual bomb itself. So this is the actual casing of the bomb here. Okay. Then they'll go through another one, another link, and then would eventually reach the detonation subsystem, which would then reach the nuclear subsystem. So this part here is actually your bomb, right? This is the warhead designs that we looked at earlier in the course. So the bomb, cannot be armed without the correct political authorization codes and the correct PALs, the military codes. In addition to that basic safety mechanism, the bomb has an additional safety mechanism, which is a tamper-proof membrane and an environmental sensor. So if the bomb detects that suddenly it's getting extremely hot outside, for example, the bomb will deactivate itself. It'll disarm its detonation subsystem. Furthermore, if the bomb detects that someone's trying to drill in through the membrane with a drill, it will disarm itself. Okay. So there are two types of inputs. One is coming in terms of authorization codes and PALs, another in terms of environmental sensors to determine whether or not the bomb is being tampered with or is finding itself in a highly unusual environment, in which case it will deactivate itself. Here's an example of what the actual engineering looks like. So this is a intent strong link. So this is for PALs coming into a bomb, and the signal will come in here, and that signal then is compared to the bomb's programming, and then is converted into a electromechanical function here, and that is the actual system that begins to then activate the detonation subsystem of a bomb. Once all that has happened, the actual launch of the ICBM requires both the political authentication codes and the PALs, right? We know that already. But it also requires a further example of the two-person rule, and that in order for an ICBM to actually be launched, once all the codes have been authorized and all the safety checks have been done, it takes two operators, one here, to actually launch the ICBM. They both must simultaneously turn a switch at the correct moment for the missile to actually fire. At the same time, in the main launch control center, other operators also must do the same thing. So you've got all of this final human element, if you like, in the chain, in the process of launching US nuclear weapons. Okay, so that's basically it. I mean, obviously it can get technically much more complicated. I've tried to stay mainly on the conceptual level here for those of you interested in delving into more detail about the various safeties, the nature of the authentication codes, the nature of the PALs, and especially the engineering of all of this, which is extremely complicated and actually extremely interesting as well. You're certainly welcome to do so, and I'm happy to point you in some directions. But I think for now, that's about as much as we need to really cover this in the course material. So by now, you should be familiar with the motives behind nuclear command and control systems, and you should be able to describe how those systems work at the conceptual level. Okay. So obviously, the big question behind all of this is, are they foolproof? Are these command and control systems foolproof? Could they be tampered with? Could they be interfered with? Is it still not possible for weapons to be used in an unauthorized manner? And the short answer is it's highly unlikely, but it remains possible. Accidents do happen. And of course, nuclear use may come about from political circumstances that are derived from miscalculation or mistake or erroneous information, right? So the whole system could do exactly what it's intended to do, but it could be fueled by a political motive that was based on erroneous information, miscalculation, or what have you. The nuclear accidents piece is really interesting. For those of you who want to follow up, Schlosser's book is a really good place to start because there have been some quite frightening accidents. And of course, some examples in the past of international crises where we came pretty close to nuclear use. So all of this makes command and control systems very important. Now project this onto other countries. We only really talked about the United States, but what does the command and control system of Russia look like? How confident are we in the integrity and the safety of that system? What about the Indian and Pakistani nuclear command and control systems? How robust are they? What about North Korea's? So the command and control discussion is really important and sometimes quite scary element of our subject. But I hope you enjoyed this video. We'll leave the subject for now, and we will see you again soon.